My name's Pete. This is a really sort of high-level introductory talk on retrocomputing. Playing around with and working with older hardware. And for this talk, I'm not going to be going into like older mainframe systems, IBM, CDC stuff. And I'm also not going to really be talking about early home microcomputers like Altair's, Commodore, things like that. What I am going to talk about is Unix machines from about the mid-70s to the early 90s. So going from like Digital Equipment Corporation, Sun Microsystems, SGI. And the reason for that is these machines, first of all, they can run more modern operating systems. Right? You can throw NetBSD on these things, sort of just runs everywhere. And that's actually the reference platform for this talk will be NetBSD. And it also has fairly good documentation. So why these particular machines? Well, they have historical significance, right? Digital Equipment Corporation started off doing laboratory equipment and then pivoted specifically to doing computing for laboratory and research institutions. And, with ARPANET, most of the machines on it by the mid-70s were some form of DEC machine. There's, if you look at a diagram of ARPANET, which I have in a couple of slides, there's a ton of PDPs on it. And so that's one reason. The other is a lot of these systems are fairly easy to get your hands on. Less so, as time goes on, but you can often find these being given away, or people that are into retrocomputing sort of have a plethora of them, trying to give them away to good homes, and they don't require special infrastructure. You don't need special cooling or power for the most part. So these things are feasible to have in your house or office or dorm room or whatever. Really, should turn it off. All right, so awesome. This is great. Hey, so right, even VAXing. The Microvax VaxStation 2000 actually came in a lunchbox form factor. So, machines that you sort of associate with big iron, you can put on your desk. So, right, so here's that diagram I was talking about. It's sort of readable, right? A lot of those machines, you see PDP-1, PDP-11, PDP-10, and VAX. A lot of people cut their teeth on VAX, and okay. Sorry. So Digital Equipment Corporation, they have the PDP-11, later VAX, VAX virtual address extensions, basically envision as a 32-bit extension to the VAX architecture. And they also had some machines based on the MIPS architecture. Those were Ultrix and OSF1 were the operating systems that sort of ship with those. And then later on, the alphas. And for the most part, with the exception of the 16-bit PDP-11, they'll all run a modern version of NetBSD. So you can get these up and running and play around with them and use them. And that's sort of the point. SGI, another fairly well-known company. More so for the graphics capability at the time, right? These were the machines that supported, video streaming and 3D rendering back when, most people were still using text terminals. And there's also a range of architectures. Most of them are MIPS. They had some x86 machines, but those, they're not particularly interesting, so we're going to talk about this. And of course, Sun Microsystems, right? They started off with M68K. It was the Sun 1. And then Spark, still around in the 64-bit variety. There was also a 32-bit version. Unfortunately, Debian discontinued support for Spark 32 and Lenny. Well, that's okay. But the NetBSD still has a 32-bit version that will work. And of course, Next. I'm going to talk a little bit more about Next towards the end of the talk. That's some interesting history, right? I mean, NextStation, the first web server was a NextStation machine. They really pioneered the sort of what we envision is modern object-oriented user environments, right? Objective-C comes from the next operating system. If you've ever done like iOS programming, programming for macOS, a lot of the libraries start with ns-dot, which is next step. That's the operating system that Steve Jobs brought back with him that influenced a lot of OS X, Mach kernel also. So right, getting these things, right? You can find them on eBay. I did some searching a couple of days ago, and some machines are pretty cheap. You can get like a Spark IPC for like 25 bucks. Some of them are surprisingly expensive, mostly due to the fact that a lot of these machines are still in use by some companies like, oh, I don't know, banks and travel agencies. And so they actually use these for, revenue generating things. So finding hardware and replacement for those as they age becomes more and more difficult. So working components are actually really expensive because they're enterprise priced now. So a good way to get machines, and actually the way that I got most of my hardware was from basically like universities throwing them out. So if you happen to come across an old machine and you're interested in older hardware, rescue it, give it a good home, play around with it. So and one thing to keep in mind, if you're just getting started, my sort of personal recommendation is find something, work backwards. Start with newer hardware and go backwards from there. Like machines like Alphas are pretty forgiving and surprisingly easy to work with. They're the boot prom is user friendly in comparison to some other systems. So how do you talk to these things? Well, the obvious thing is, well, there's serial console, right? Everything speaks serial. It's a good interface. Using machines like this as a workstation can be difficult if you don't get all of the hardware together, right? Most of these things, well, they're not quite VGA. Maybe they're not quite any sort of now standard video signal. They may just be, BNC feeds for red, green, and blue, or monochrome. Finding peripherals, keyboards, and mice can be challenging. So the easiest thing to do is, you can get a PL2303 serial adapter, USB. It runs on everything. There's drivers for Linux, Windows, OS X, and that's really the best way to get started. You don't need to worry about monitors, and basically you're reducing the number of failure-prone components. So another option, of course, if you want a really traditional experience, is to get a serial terminal. A VT100, ADM3As, ADM5s are, sort of a fun way to get a very authentic experience. But again, it introduces an additional maintenance component. So, right, hard drives, they fail, right? When your hard drive is 25 years old, it will definitely fail. You really should make use, wherever possible, of net booting. And it's a bit more work, right? There's more setup involved. There's more things you need to be aware of, but sort of worth it in the long run because, well, you'll be able to, share environments across machines. If you have a couple of identical machines, they can share most of the file system and, shared home directories and goodness like that. And also you can, offload all of the storage onto newer hardware that is, if it fails, at least it's replaceable. So, right, you'll get some experience with older networking technology if you decide to play around with these things. You'll get very familiar with 10base2 and ThinNet, and you'll experience the joy of transferring a kernel image over ThinNet. I suggest that you start the boot process, go get lunch, and come back a little bit later, because it can take some time. You can find AUI twisted pair transceivers for like $5. Pretty easy to come by. A lot of machines of this vintage usually have, if they have an integrated network card, will have an AUI interface. So if the other option is we'll have an AUI interface in ThinNet. Well, if you don't want ThinNet, you can pop a transceiver on it, and really, and then you're good to go. Let's get old. So right, to bring up a system, obviously you need an operating system on useful media. So you have a couple of options. Tape, that's always fun. Or floppy disks, that's extra fun. Or if you're lucky enough, so newer machines like Alphas and the Spark 64s, they have PCI buses. You can put, I have a SATA card in one of my Alpha machines because it works. You can do that. So you can actually get CD-ROM drives in some of them. There's also SCSI CD-ROMs, although there's some weirdness that you have to be aware of. They're not all identical. Obviously, there's a variety of different types of SCSI, and they're not all cross-compatible, as well as there's some proprietary, like Digital Equipment Corporation, their CD-ROM drives will not work in Sun Microsystems machines for the most part. Just something to be aware of. So, right, net booting, probably the best way to go. Right. So what do you need to net boot? Well, if you're running a VAX, right? VAX, there's a management protocol, MOP, it's Digital Equipment Corporation specific. And there's MOPD on NetBSD. So basically you give it a kernel image to load, and it goes ahead and does it. It basically combines reverse address resolution as well as a TFTP in sort of one package. Otherwise, you'll need some way for the machine to get an IP address. Usually this is done with RARP or BootP. And DHCPD, or DNS mask, is actually a really useful utility. It combines a dynamic DNS server, DHCP server, BootP, and TFTP in one nice package. So if you want sort of a one-stop shop for that stuff, that's I highly recommend it. And it's available on Linux as well as NetBSD. And obviously you need NFS to provide the file system. So there's some conventions, and one of the reasons that I like using NetBSD for these systems is they have really good documentation when it comes to the specifics that some machines require, right? So Vaxin with MOP will look for a file, the MAC address of the system.sys, and that's what it will boot for. Sun machines, specifically the Spark 32-bit machines, actually look for a file name of the MAC address or the IP address in hex dot whatever the architecture is, so like Sun4C, Sun4M. And newer machines, the Spark 64s and Alphas, you can actually specify the boot file in the PROM, which makes that much more simpler, which is another reason why I recommend starting newer and working back. One thing to also keep in mind is embrace plain text, right? These machines are often not computationally fast enough to make SSH useful. I suggest creating basically a separate plain text network that you put these machines on, and that way you can use things like Telnet and rlogin and not have to worry too much about what's going on. If you really don't want to send passwords in clear text over the wire, you can use Kerberized Telnet, and then you at least have your login part protected, and the rest of the traffic obviously is still in the clear. And also, if you're one of those people that worries about tempest emissions, these machines generate quite a bit of EMF noise. So this is an example setup of some stuff that I have in my basement, right? So there's the rest of the network, right? And I have a x86 NetBSD box that has all of the right things that you need to boot a machine. So you have NFS and a BootP server and DHCP server, etc., and a ThinNet card, which powers most of the hardware, as well as a serial console server, which is useful because then you don't have to walk around with a serial cable and plug in each one. You can just telnet into the thing, and then you get console. So right, why bother? Why even deal with old hardware, right? So sure, there's a cliche in the industry, right, that everything's obsolete on launch, right? And obviously that's BS, but it's interesting to see what you can do with limited resources, right? And that's sort of relevant today, right? Because you have things like Internet of Things and embedded devices, and those are becoming more and more common. And yes, you can get, like my phone, which is tiny, has a tremendous amount of computing power, but when you work with things like, SCADA and microcontrollers, obviously you have fewer resources, and sort of the nifty tricks that engineers did 20 years ago to get the most out of this hardware, that's an interesting perspective to have. You may approach things a little bit differently, having had experience working with slower systems. You're more aware of, how long some operations take to run, and more mindful of, what limited resources, what those constraints are. And, also you sort of get a little bit of a deeper connection to the hardware, sort of the same way that, people like classic cars, basically, the geek equivalent, right? And there's also some nifty little historical footnotes, right? So the ADM terminal, right, was one of the terminals that was used a lot in the development of Unix. And the home key and the tilde key on the ADM terminal are the same key, which is where the shortcut for home in Linux and Unix systems come from. Also, the arrow keys on that machine were on HJKL, which is where navigation and things like them come from. And I talked earlier about next step, right? The mock kernel, the NS prefix. Also, the funk sound in OS 10 is the same one that was in next step. They even carried over a lot of the media. And, VMS in the 80s supported things that are still sort of hard problems now, right? VAX clustering through DECnet allowed, a dynamic reallocation of processes in the cluster. You can do rolling reboots and rolling upgrades. And they had, systems with 16-year cluster uptime because they could just, upgrade the machine as they went. And these are still things that are sort of challenging in IT environments now. What they say, the joke is nothing is ever new in computing. Cloud computing and web applications are basically time-sharing 2.0. Right, thank you for showing up so early. My contact info, you can find me at friedman.org or at pfriedma. Those resources I listed are really fantastic, especially the ManX is basically a collection of PDF scan manuals for a whole bunch of machines. If you need a maintenance manual for a PDP-1, they've got it. And also, as I mentioned, the documentation on NetBSD is really fantastic. So just any questions? Comments? You should have turned off Xlog. All right, well, thank you very much for coming.